Hello everyone, welcome to my sixth video in this series on end-to-end big data pipeline. Today we will see a very interesting topic utilizing AWS Toolkit to access AWS resources and storing and utilizing passwords via Secret Manager and AWS CMK. By the end of this video, we will get to know about how to access AWS resources seamlessly using AWS Toolkit in IntelliJ. What are the best practices to secure credentials and key management? We will learn how developers should store their credentials and keys securely in their local, how to create a customer managed key for securing passwords. We will see how to encrypt and encode passwords using CMK, followed by decrypting and decoding these credentials. We will streamline our development process by setting up Jenkins and the necessary plugins, and then we will store and use credentials like a pro within Jenkins. And at last, we're gonna seamlessly integrate these credentials into our Dockerized code deployed in production. So these are the steps we're gonna follow to accomplish our goals. Let's start with creating IAM User and setting up AWS Toolkit in IntelliJ. Let's start by creating an IAM User. Click on IAM. Click Users, Create User. Give any username. Let me give developer. Click on attach policy. For now, let's not attach any policy and click next and create user. Now let's generate access key and secret key. Click on user you created right now. Go to security credentials. Click create access key. I'm selecting other. Click next and create access key. Store these credentials with yourself. Now open IntelliJ. On right side, click the setting icon. Go to plugins and select AWS Toolkit and install it. Click apply and then OK. Ignore this pop-up, as in my case I already had some keys which I deleted. Now restart your IntelliJ. Go to edit AWS credentials and give access key and secret key which you copied right now. Now you can see all these AWS services, and if you want any other resource you can click on resources section and add it, provided you should have access to that resource. As of now it is showing this error because this developer user has not even access to list the available resources in AWS. So let's give those access to this user. Click on create inline policy. Click JSON and allow CloudFormation list type and list resources action. And now in resources we can see all the services which we want to see. We can even add or remove any of them. You can see we have list of all these AWS services. You can select any of them and it will appear in resources section. For example, click RDS and select all. You will only be able to see inside it if you have got access to it. Let's see how to access S3. Click on S3. Nope, you're not able to access any resource inside it. Let's go to AWS S3 and create a bucket. Give it a name. I'm giving YouTube chapter 6 temporary bucket. Click create bucket. Even now we won't be able to access this from IntelliJ. Go to IAM. Go to user you created right now. Attach policies. Let's give Amazon S3 full access for now. And now if we refresh it, we can see that bucket. Let's try deleting bucket from here. It's deleted. Now let's remove this S3 full access. Now let's see how to create customer managed keys. Go to key management service, click on create a key, select symmetric as key type and encrypt and decrypt as key usage. Give some alias. I'll give a test master key. Give access to developer to use this key. In ideal scenario, this is given to DevOps or admin guy of your team. And finish. And yes, our key is created. This is the key. Now let's see if we can see this key on IntelliJ using Toolkit. Nope, we can't. Let's give access to developer to see this these keys. Search for KMS related policies. Select ListAliases, ListKeys and DescribeKey. Give access to all resources. Click next. Give a suitable policy name. List KMS keys. Now go to IntelliJ and refresh AWS Toolkit. Yeah, now you can see keys for which you got the access. Now let's see how to encrypt and decrypt password using this CMK. This is my encrypt password file. In production, make sure that this encrypt file is not present in repo. It can be anywhere in your local. We will encrypt using a Spark scaler. Let's import the necessary modules and start the Spark session. Initialize KMS client. Give a password which you wish to encrypt. Now I am giving a generic one, +1 @ 123. Now get CMK which you have just now created from environment variable. Add this customer master key in environment variable first. Get the key from AWS Toolkit, copy it and paste it in environment variable. Let's run it. This part will encrypt using AWS KMS. And with this snippet, it will get encoded in base 64. And this will print out the encrypted password. This is my encrypted password for +1 @ 123. Let's save this password somewhere. We will take this password and try to decrypt it using customer managed key. Open decrypt.scala code. Again, most of the codes are same as encrypt. Import necessary modules and start a Spark session. Initialize KMS client and you can input that base 64 encoded message that you have saved right now. This will decode the password and using customer managed key, it will decrypt your password. And then you can print out your decrypted data. Let's run it and then enter the encoded message. Okay, it looks our CMK coming from environment variable is wrong. So let's fix it. Go to AWS Toolkit. Again, copy the KMS key, put it in environment variable. And apply. Again, let's run it. Paste the encrypted message. And here we can see the decrypted password +1 @ 123. Now let's come to the fourth step. Here we will see how to store this credential in Secret Manager and use it from code. Go to Secrets Manager, store a new secret. Let's click other type of secret. Give a random key. I am giving XYZ database password and will put my encrypted password here. Then select the key which you have created, test master key. Now let's give a name to the secret. I'm giving dev XYZ database. Next. I'll be using this Java code in a Scala way. You may use any other language depending on your need. Now let's store the password. Yep, here's my secret. Let's come to code. Come to this file and get password from Secret Manager. Let's see the code which we have taken from AWS documentation, which I just showed you guys in Java. We will import these necessary models and then initialize Secret Manager. Give that secret name which you just created. Let me copy it. And here give the secret key for what that secret value maps to. And then we will get that encrypted key which we further need to decrypt it. This is the same decrypt code which I told you a few minutes back. You need to pass that customer managed key to environment variable. And run the code. Okay, here our user developer doesn't have access to use Secret Manager. Go to IAM User and add permission. Create inline policy. Click JSON. Search for Secret Manager and click Get Secret Value and give access to all resource which you can restrict based on your project. Give a name to this policy and create it. Now let's run it again. Yes, we got this encrypted password from Secret Manager and then we decrypted it. You can use these passwords in your JDBC connection like this, which will make it safe and secure. So till now you have seen how a developer should save key in environment variable, access AWS resources using AWS Toolkit, save AWS credentials in local. Now how can we do this in production? For this we need to set up Jenkins. Set up your cloud VM. Make sure that Java 11 is already installed there. Install Jenkins in your VM. You can install the required plugins which can be helpful either in this project or in near future. I've shared the list in description. These are the plugins which you need to install. Then restart the Jenkins. And then let's create our first job. Let's name it test project 1. Click GitHub project. Give project URL. Let me go to GitHub and open this repository. Paste it. And now paste repository URL. Put branch name. Now we will just do ls to check if it is working fine. Yup, it is. Now go to your virtual machine where Jenkins is installed and give root access to Jenkins user like this, so that it can run sudo commands which we will need later. Also give Docker access to Jenkins user. As already mentioned that Java 11 should be installed in your VM. Also we need to install SBT. Go to this URL and follow these steps. I have even attached it in description. Go to your project, open it, go to framework, jobs, controllers. This is my base controller which rest of the controller is gonna extend. This is the new object, service decrypt environment variable. Please ignore this weird object name. It calls for this class read environment variable. Again, apology for this class name. You can certainly give a better name. And now let's go to that class. Here we have variables secret ID and customer master key, which in local we were taking from environment variable. And we have this function get and decrypt secret. We have just now seen the code that how it works. I have just put it in this function which takes secret ID and KMS key which we have to provide. Secret ID will be there in code depending on the requirement that which secret we need, and KMS key we will provide from outside through environment variable in local and through Jenkins in production. And rest of the code is same. Open the Docker Compose file. Pass customer master key, AWS key and AWS secret key as variable in your Docker Compose. Now go to manage Jenkins and give all these three things in credentials. By simply going to global and add credential. I won't be doing it as I have already added it. Now go to your job and go to build environments. Use secret text. Add all those three keys and secret which you just created. Put these in property content in these variables. Through these commands we will build the Docker image which we saw right now, and then we're gonna build jar using sudo sbt assembly and put this jar inside Docker container using docker cp command. Let's build the job. And here we can see containers are creating and jar is getting built and job is successful. Now let's go to the VM. We could have automated this too, but I wanted to show you how it runs. Switch to Jenkins user and go inside container. Through Jenkins itself, jar is added in my jar folder inside the container. And now let's run a spark submit command and run that job which decrypts the password. Here we can see the password is decrypted. So that's all I had for this video, and do like and subscribe to my video. You can get this code from my repository. I have attached the link down below. You can follow me on LinkedIn and Medium. I have attached blog for the same. Thank you and keep coding.